All right, check out this argument. If it is snowing, then the mail will be late. It is snowing, therefore the mail will be late. What we want to know is this. If the premise statements are true, is there any way that conclusion statement could be false? Or is it impossible for the conclusion to be false when the premise statements are all true? We can construct a truth table really quickly that will definitively answer that question for us. And the way we're going to do that is this. We're going to begin by identifying the simple statements that make up our argument. In this argument, we have the statement, it is snowing, and the statement, the mail will be late. And we're going to assign each of those simple statements a letter and then use operators to represent the different statements in this argument. Now what we want to do is we want to symbolically represent this argument on a single line. Okay, so we're going to begin with the first premise. If it is snowing, then the mail will be late. That is a conditional statement, and we can translate that using S and L with a horseshoe. So S horseshoe L is the translation of this first premise. But now we've got to move on to the second premise, and we want to stay on the same line here, but we also don't want to create confusion about where the first premise ends and the second premise begins. So what we're going to do is we're going to separate our premises, all of them, no matter how many there are, we're going to separate them from one another using a single slash. That single slash tells us the premise on the left-hand side is ended, and now you have another premise on the right-hand side, S. And now we want to represent our conclusion statement, again, on this single line, but we don't want to create confusion with our premise S. So what we want to do is we want to separate the last premise from the conclusion using a double slash. And then we can put our conclusion statement L, and now we've got this argument written out on a single line, and it's really clear where the premises begin and end and where the conclusion begins and ends. Okay, so now what we're going to do is we're going to use our old pal L equals 2 to the n to help us create a truth table for this symbolized argument. And we know that the number that's going to go in the n position here is the number of unique simple statements that we're working with. And here we have exactly 2, S and L. So we're going to put 2 in the n position, calculate that out to get 4, and that's telling us, okay, draw 4 lines. Your truth table needs to have 4 lines. And of course, now we're just going to keep using our equation here, L equals 2 to the n, and we're just going to keep dividing this number that we keep calculating by 2. So 4 divided by 2, that tells us, hey, you know what? Go to the first letter on the left-hand side of your truth table, and I want you to put 2 T's followed by 2 F's. Okay? And you want to make sure that you put the exact same truth values for S on each one of these lines, because each line represents a particular moment in time. And because no statement can be both true and false at the same time, if S is true here on lines 1 and 2, it has to be true here on lines 1 and 2 as well. Same thing with being false on lines 3 and 4. If it's false there, it's got to be false there. And again, we can come back to our number, divide it by 2, and that's going to tell us 1. And that says, you know what, put alternating T's and F's under the next letter and make sure that you're consistent. If these are the truth values for L here, they need to be the same there. All right, and now what we can do is we can calculate for all of our operators. In this argument, we have only one. It's this horseshoe here. And we know that anytime the left-hand side of a horseshoe is true and the right hand is false, the horseshoe is false. All other true-false combinations result in that horseshoe being true. Now think about what we've done here in really short order. We've created a visual representation of all of the possible truth values for the statements that comprise this argument and its operators, okay? All of the possibilities are here in front of us. And so what we want to know now is, okay, I see 4 possible arrangements of truth values. Does any one of them reveal that it's possible for the conclusion of the argument to be false at the same time all of the premises are true? So what we're going to do is we're going to zero in on any time the conclusion is false. That's the only line we're concerned with. The only lines we're concerned with are the lines where the conclusion is false. And what we want to know is, on those lines where the conclusion is false, are all of the premise statements true? Well, let's look. Line 2 and 4, these are our critical lines. On line 2, the first premise is false and the second premise is true. And on line 4, the first premise is true and the second premise is false. What does that tell us? It tells us this argument is valid because we've got all of the possibilities laid out in front of us, and it's not included as a possibility that the conclusion is false at the same time all of the premises are true.